India's foray into the space research started in the early 1960s, when the satellite applications were in the experimental stages worldwide. Dr. Vikram Sarabhai, a visionary behind India's space program, had strong conviction that the space technology could be effectively leveraged to tackle the problem of society and the country. The Indian Space Research Organization, ISRO, was founded in August 1969, and it was brought under Department of Space in September 1972. The prime objective of ISRO is the development of advanced space technology and application of space technology for societal, commercial, developmental, and strategic requirements of the country. While the 1970s were the period of conceptualization, the 1980s were the period of experimentation, which saw the demonstration of end-to-end capabilities through Aryabhatta, Bhaskara, Apple experimental satellites, and SLV and ASLV development launch vehicles. These initiatives laid a strong foundation for realization and deployment of operational Indian National Satellite System, INSAT, Indian Remote Sensing Satellite System, IRS, and for development and operationalization of Polar Satellite Launch Vehicle, PSLV. ISRO functions through various centers and units located across the country. ISRO has been making a steady progress in development and deployment of state-of-the-art infrastructure and systems. ISRO has successfully developed different class of launch vehicles for launching satellites of different payload capabilities. The PSLV, GSLV, LVM-3 and SSLV have shown their precise performances in placing satellites to various orbits of Earth, including LEO and GEO, further to the orbits of Moon and Mars. Recently, ISRO successfully conducted the demonstration of autonomous landing of reusable launch vehicle, RLV LEX. Further, ISRO is pursuing its endeavors to develop next-generation launch vehicle with higher payload capability while offloading the operational launch vehicles to industry. ISRO has launched fleet of communication satellites, including high-throughput satellites, into the geostationary orbit for meeting the requirements of television broadcasting, VSAT services, internet broadband, cellular backhauling, island connectivity, telemedicine, and tele-education applications. ISRO has launched several Earth observation satellites, namely Cartosat, RESAT, OceanSat, and also meteorological satellites for various applications in Earth and ocean resource monitoring, resource management, geospatial applications, and for weather and climate applications. The satellite data are regularly provided to various user ministries and other users. These satellites play a significant role in disaster management in the events of floods, forest fire, earthquake, landslide, tsunami, etc., saving valuable lives and assets. The satellite data have been consolidated, value-added, and made available to various users through platforms like Bhuvan, Mosdak, and Vedas. Several government and private users are deriving the benefit out of these portals. NAVIC is the navigation system of India with a constellation of satellites operating from geostationary and geosynchronous orbits. NAVIC provides the position, navigation, and timing services for civilian and strategic applications. ISRO is continuously contributing to the capacity building in space infrastructure and human resources in the country through various sponsored R&D programs and outreach activities. ISRO actively collaborates with other space agencies and organizations worldwide. It not only partners with the spacefaring nations, but also works with space-aspiring nations in sharing expertise in space technology and applications. ISRO's contribution with space science missions, namely AstroSat, Aditya L1, and ExpoSat, is significant for the space research. Several national and international researchers and institutions have made use of the data from these satellites and brought out publications in renowned international journals. ISRO also undertook space exploration missions of Chandrayaan and Mars orbiter missions to study Moon and Mars, while developing the critical technologies. India has successfully landed its Vikram lander of Chandrayaan-3 closer to the southern polar region of the Moon. It has also deployed Pragyan rover to explore the lunar surface. These missions have not only expanded scientific knowledge but also have garnered international acclaim. Efforts are continued to scale new heights in this journey. Gaganyaan project of ISRO envisages demonstration of human spaceflight capability. The mission is to orbit Indian astronauts at 400 kilometers altitude for 1 to 3 days and bring them back to Earth safely. Various precursor missions are in progress for demonstrating the technology preparedness levels before carrying out the actual human spaceflight mission. These demonstrator missions include Integrated Airdrop Test, Pad Abort Test, and Test Vehicle Flights. Safety and reliability of all systems will be proven in unmanned missions before the manned mission. As announced by Honorable Prime Minister of India,
2035 तक अंतरिक्ष में भारत का अपना स्पेस स्टेशन होगा जो हमें स्पेस के अज्ञात विस्तार को जानने में मदद करेगा.
ISRO is working on realizing an Indian space station, namely Bharatiya Antariksh Station, by 2035 and to land an Indian on Moon by 2040. The journey of Indian space program continues to grow to serve the nation, the citizen and the humanity at large.
He saw science as a way of life.
He had the idea that we should use science and technology to leapfrog.
And Dr. Sarabhai had picked up the idea from Gandhiji's basic idea that the development that we are looking for, economic development, the social development and all other things, will happen only through education.
Even today, if you ask me the use of space for societal application, nobody can emulate India.
And that every institution he started, every thought he left behind was with the belief that we could do it. We did not have to depend on others.
I'd say longevity, because he was able to lay the foundation, such a strong foundation for so many institutions.
You have to take several people and put them together, and then what you get is one person, that is Vikram.
On August 12, 1919, a wealthy family of textile mill owners was blessed with a boy in their home Retreat at Ahmedabad. His parents, Sarla Devi and Ambalal Sarabhai named him Vikram. On in school days, Vikram became proficient in all subjects, but his core interest was always in mathematics and science. After his schooling in Ahmedabad, Vikram went to Cambridge in 1937 for higher studies. After earning PhD, he came back to India in 1947 with much widened horizons and tremendous zeal for nation building.
When he came back from Cambridge after completing his PhD in 1947, and India had just won freedom, that's when you kind of see Vikram's grand plan, if you can sort of put it like that, unrolling one by one.
The conditions of the society in the nascent free India troubled him deeply. He strongly believed that it was science and technology alone which could solve the real problems of Indian society.
In my opinion, the aspect of space research which I would like to stress most is in relation to the national capability, the self-confidence that this will generate.
He started in right earnest on the path of realizing his vision by founding Physical Research Laboratory in 1947. With this, he set the pace and charted the course for India to leapfrog generations of technology and rapidly develop into a scientifically advanced nation. He next established Ahmedabad Textile Industry Research Association, ATIRA, for modernizing textile industry in India in 1947. From 1950 to 1966, he set up and managed a number of industries. Dr. Sarabhai started working towards formation of the Indian space program in 1961. He recruited talented scientists like Dr. APJ Kalam, Arvamudam, H.G.S. Murthy, Ishwar Das, Ramkrishna Rao, Prakash Rao, and many others to join him in this task. He canvassed around the world for bringing technology and scientists settled abroad to India. He nurtured cooperation with the advanced nations like USA, Russia and France for setting up basic facilities. In 1962, the government formed Indian National Committee on Space Research, INCOSPAR, chaired by Dr. Sarabhai, within the Department of Atomic Energy. He established Thumba Equatorial Rocket Launching Station, TERLS, at Trivandrum in 1963.
He knew that all the sounding rocket sites in Western countries were in the middle latitudes or near North Pole. There were no equatorial sites. And so he said Thumba would be an equatorial site which would be of great interest to international scientific community.
In November 1963, the first Nike Apache rocket successfully flew from here and is today regarded following the untimely demise of Dr. Bhabha in January 1966. Dr. Sarabhai became the chairman of Atomic Energy Commission, but deep down, he always wanted to explore new concepts for societal development. He initiated a study on the cost and significance of synchronous satellites to link the distant rural communities to the mainstream. For this, he established the Experimental Satellite Communication Earth Station, SKES, in Ahmedabad, and envisaged a phased national television program.
Particularly in a country like India, where the large mass of people who have to be motivated are illiterate, it is very important to, I think, have the information input as an integral part of the developmental process. And I think a powerful technique like a audiovisual presentation through television can be one of the most important motivations, a catalyst for action.
The Indian Space Research Organization was constituted in 1969 with Dr. Sarabhai as its first chairman. In the same year, he signed an MOU with NASA to conduct the Satellite Instructional Television Experiment, SITE. Under this, NASA would loan ATS-6 communication satellite to India for 1 year. ISRO would arrange the necessary ground hardware and community television receivers for conducting this experiment, wherein television broadcast was to be carried out via a satellite.
So that was a remarkable precursor to all that we are doing today with the communication satellites, in the case of education, in the case of health, and of course doing communication for broadcasting, for television programs, and many other kinds of news and telephony, telegraph. Everything that you think of in the today INSATs are being used in a big way.
SITE, though conducted after his death, proved to be one of its kind in the world, and eventually led to revolution in this field of direct-to-home TV. Meanwhile, Dr. Sarabhai and team operationalized Sri Harikota Range, Shar, on October 9, 1971 with the flight of Rohini 125 rocket. Known as Satish Dhawan Space Center, Shar, today it is a world-famous spaceport. A large number of other institutions like Darpana Academy of Performing Arts, Ahmedabad Management Association, Indian Institute of Management, Nehru Foundation for Development, Community Science Center in Ahmedabad and ECIL Hyderabad also owe their existence to Dr. Sarabhai. As dawn broke on 30th December 1971, the nation received a rude shock. This great son of India, the father of Indian space program, had already taken his last breath. Dr. Vikram Sarabhai passed away at an age of only 52 years. He received S.S. Bhatnagar Award in 1962 and Padma Bhushan in 1966. He was posthumously awarded Padma Vibhushan in 1972. In 1974, the International Astronomical Union, Australia, named Beazle Crater in the Sea of Serenity on the Moon as the Sarabhai Crater.
He lived for humanity, he lived for India, he lived for a nation that could blaze a trail, and I think his life was a blaze. And I think genuinely that had he lived, many things would have been different in this country.
For the last 70 years, practically every day I have grieved what this nation has lost.
From 47 to 71, in 24 years, he came out with more than 35 institutions, more than 100 scientific research papers. So many students did their study under him in both MSc as well as PhDs.
Love for science, love for the country. He was really, I mean, people that I interviewed use, you don't normally use the word love, particularly, but I found repeatedly, he was in Kalam, APJ Kalam says, he was in love with the space program.
It is not the space program itself, but the way the space program has been built, which is important, of how generation after generation of people take on that leadership and with the same thrust go forward. You see so many institutions which really don't do that.
One of the things he did, and I mentioned earlier that he left this behind into the organization's DNA, was to motivate people from the point of view of what the end goal was. To make you feel that what you were doing was part of a larger whole which contributed to something big.
He actually gave the whole nation a dream of satellite communication and reaching out to rural areas.
I think what important thing that he left behind was his ideas, and he had shared as to what exactly is required to be done.
We have just fulfilled everything that Sarabhai had visualized, and most importantly, they are a sustainable set of activities which will make the space relevant to this country all the time to come.
A dedicated scientist, an institution builder, a kind human being, a versatile personality, a great patriot, but above all, a dauntless visionary, who was passionate of using science for the benefit of society. India truly remains indebted to her great son, Dr. Vikram Ambalal Sarabhai.
India's foray into space research started in the early 1960s, when satellite applications were in the experimental stages worldwide. After witnessing the importance of space science, Dr. Vikram Sarabhai, the visionary behind India's space program, quickly realized the application of space technologies for India's mass communication. He had a strong conviction and a visionary outlook, recognizing that the vast resources in space would tackle the real problems of society in the country. He gathered a team of exceptionally talented and highly skilled people, including scientists, anthropologists, communicators, and social scientists from all over the world to lead the Indian space program. In order to lead the space research activities, the Indian National Committee for Space Research, INCOSPAR, was established in 1962 within the Department of Atomic Energy. Following that, the Indian Space Research Organization, ISRO, was founded in August 1969, replacing INCOSPAR. In June 1972, and houses the solid motor production and test facilities and the launch base infrastructure, the assembly and integration facilities, launch pads, satellite preparation, tracking and telecommand systems are part of the launch complex. The development of liquid stages and cryogenic stages is carried out at the Liquid Propulsion Systems Center, LPSC, in Baliyamala and Bengaluru. IPRC has cutting-edge assembly, integration and testing facilities for qualifying the liquid, semi-cryo and cryo stages. ISTRAC, located in Bengaluru, is entrusted with the responsibility of providing tracking support for all the satellites and launch vehicles. Master control facilities at Hassan and Bhopal will take control of satellites after injection and subsequent maneuvers of Earth observation satellites and continuous monitoring of communication satellites in the orbit. The National Remote Sensing Center, NRSC, in Hyderabad is responsible for the reception, processing and dissemination of data for remote sensing satellites. ISRO has launched several Earth observation satellites, namely Cartosat, RISAT, ResourceSat and OceanSat for various applications in the geospatial domain and continuously provide satellite data applications to various user ministries and other users. ISRO also launched a fleet of conventional and high-throughput satellites in the geosynchronous orbit, which extends broadband, mobile and weather-related services to the users. NAVIC is the navigation system of India, with a constellation of satellites launched in geostationary and geosynchronous orbits to meet the position, navigation and timing services for various users, including strategic. ISRO also created records in the interplanetary missions like Mangalyaan and Chandrayaan. ISRO Space Mission AstroSat, Aditya L1 and ExpoSat have been contributing immensely for the space research community through various research institutions across the country. The satellite data has been consolidated by ISRO and made available to various users through platforms like Bhuvan, Mosdak and Vedas. Several government and private users are deriving benefit out of these portals. ISRO is constantly and continuously contributing to the capacity building space infrastructure and human resources in the country through various sponsored R&D
Mangalyaan successfully visited Mars on its maiden voyage. On September 24, 2014, India garnered international recognition for successfully inserting the Mars Orbiter mission, MOM, into Mars orbit on the first try.
हमारे वैज्ञानिकों का पुरुषार्थ था कि मंगलयान की सफलता और पहले ही प्रयास में सफलता विश्व के अंदर हमारे लोग मंगल के कक्षा में प्रवेश किया, वहां तक पहुंचे, ये अपने आप में हमारे वैज्ञानिकों की सिद्धि थी.
Despite the fact that this feat has previously been accomplished by advanced space agencies multiple times over. It's the fourth country to reach Mars orbit. After leaving Earth, the spacecraft MOM covered 650 millions of kilometers in her 300-day journey to Mars. The success of the mission, in the words of Honorable Prime Minister,
आज मॉम का मंगल से मिलन हो गया. आज मंगल को मॉम मिल गई.
Ultimately, it completed 7 years of mission life despite being designed for 6 months. India's ability to send spacecraft into interplanetary space was demonstrated by this mission. Thanks to satellite navigation, it is now next to impossible to lose your way in modern times, as it can pinpoint your location to within few meters, wherever you happen to be on Earth, just in no time. The Indian Regional Navigation Satellite System, now called the Navigation with Indian Constellation or NAVIC, provides the users of the Indian subcontinent extending to 1,550 kilometers around the Indian landmass with a position accuracy of better than 10 meters and a timing accuracy of better than 40 nanoseconds on a 24/7 all-weather basis. All this may look simple to the user. However, in the background is operating a very complex process, starting with the satellites up above the world and ending with the users with the receiver devices on ground. And connecting the two is the lifeline of any satellite navigation system, the control stations on ground. The space segment, that consists of a constellation of 7 satellites with onboard atomic clocks along with their downlink signals. Of the 7 satellites, 3 satellites are placed in the geostationary Earth orbit, while 4 satellites are placed in inclined geosynchronous orbit. The network of satellites work as space landmarks, as we always know their positions, just like the landmarks we have on Earth. Each of the NAVIC satellites weighs approximately 1,425 kilograms and have been designed, fabricated, integrated and tested at the U.R. Rao Satellite Center based in Bengaluru. The navigation satellite payload, the equipment that essentially provides the broadcast signals, is developed by the Space Applications Center located in Ahmedabad. Second is the ground segment that works 24/7 to maintain and monitor the NAVIC constellation and manage the operations of the satellites and its associated facilities. The ground segment comprises of the ISRO Navigation Center (INC) at Bengaluru and Lucknow, established by the ISRO Telemetry Tracking and Command Network (ISTRAC). The INC, along with the IRNSS Network Timing Center, IRNSS Range and Integrity Monitoring Stations, IRNSS CDMA Ranging Stations, the Navigation Control Center and IRNSS Data Communication Network enables position, navigation and timing data broadcast by the satellites. The ground segment also comprises of the IRNSS spacecraft control facilities at Master Control Facilities, Hassan and Bhopal, which maintains the NAVIC satellite constellation. The third and last segment is the user segment. This consists of receiving devices that you carry with you for navigation. All the 3 segments work together to provide position, navigation and timing service to the users, be it on the surface or above it.
The IRNSS satellites transmit a time-stamped radio signals in two different frequencies at 1176.45 MHz and 2492.028 MHz respectively, which helps in providing timing information to the receiver for acquiring the signals. For time accuracy, the satellites transmit their signals controlled by on-board atomic clocks, which have a stability of better than 10 to the power minus 13. This means that unlike the ordinary clocks, which tend to lose or gain a few seconds after a few days, this atomic clock is stable enough not to lose or gain even 1 second for almost 10,000 years. It has to be so accurate because even an error of 10 nanoseconds could lead to a degradation of position accuracy by about 3 meters. These rubidium atomic frequency standards RAFS are used for accurate time stamping of navigation signals. The ground-based IRNSS receivers sense the time-stamped signals emitted by IRNSS satellites. On ground at the ISRO Navigation Center, the IRNSS network time is generated through an ensemble of active hydrogen masers, cesium clocks, and passive hydrogen masers. The INC ensures that all the onboard clocks are synchronized to the IRNSS network time. The IRNSS network time is in turn steered to Indian Standard Time IST, generated by the National Physical Laboratories, New Delhi, who are the official timekeepers of the nation. The IST has the required accuracy, stability and traceability to the universal time. The IST division of NPL generates time and frequency traceability to ISRO through a two-way satellite time and frequency transfer TWSTFT system, which is used for comparing two remote clocks with an accuracy of about 1 nanosecond. TWSTFT signal is transmitted in the Ku band from one station to other station using a geostationary satellite GSAT-8 spacecraft. The INC gets one-way ranging data from IRNSS range and integrity monitoring stations located in 16 different sites spread across the country, including Port Blair and Lakshadweep, and one located outside the country in Mauritius. INC also gets two-way CDMA ranging data from stations located at 4 different locations, one each at Hassan, Bhopal, Jodhpur and Shillong, which are equipped with an 11-meter full-motion antenna system to achieve better accuracy in orbit determination. The data received from all these stations is remotely monitored and controlled through the IRNSS monitoring and control system from a centralized console at INC. This enables to achieve range accuracy at sub-meter level, which helps us to always know the accurate orbit determination of the satellites. International laser ranging data is used for the purpose of calibration. INC generates the navigation data that needs to be broadcast by the NAVIC satellites. All elements of the IRNSS ground segment are linked through reliable communication links called the IRNSS Data Communication Network. The mirror facility called INC2 is also operational at Lucknow. This will ensure redundancy and uninterrupted availability of the NAVIC system. The NAVIC receiver consists of single and dual frequency receivers on a wide variety of platforms. All ISRO networks like MCF, IceTrack, SHAR now use NAVIC timing receivers for network time synchronization, satellite launch and tracking operations. 5 national power grid sites are now installed with NAVIC receivers for power grid control, measurements and monitoring applications. NAVIC is also now being integrated into Qualcomm's Snapdragon 720G, MediaTek Helio M70 and Broadcom BCM 47765 mobile chipsets. The day isn't too far off when the entire nation will switch over to NAVIC, making India truly Atmanirbhar.
The moon, a well-known visible object in the night sky, has captivated the minds of both scientists and common people. The charming allure of the moon has enchanted people throughout history. Scientists believed the moon would reveal the mysteries of the solar system and our own planet Earth. This mysterious puzzle has fueled numerous expeditions to our celestial neighbor. India achieved a significant milestone in space exploration when Chandrayaan-1 was successfully launched on October 22, 2008. The spacecraft carried a total of 11 scientific instruments. It orbited around the moon at a height of 100 kilometers from the lunar surface for chemical, mineralogical and photogeologic mapping of the moon. With the suggestion of former President Dr. APJ Abdul Kalam, ISRO achieved a remarkable feat by creating the Moon Impact Probe, which became the first Indian object to touch the lunar surface. This accomplishment is a testament to India's innovative approach and dedication to space exploration. The presence of water, H2O, and hydroxyl, OH, on the lunar surface was a groundbreaking discovery of the Chandrayaan-1 mission and opened up new possibilities for lunar exploration. The follow-on mission, Chandrayaan-2, was successfully launched on July 22, 2019 by the ISRO's heavyweight LVM-3 M1 launch vehicle. The Chandrayaan-2 satellite was made up of orbiter, lander Vikram and rover Pragyan. The orbiter is still healthy and continuing its observations about the lunar surface. The suite of orbiter payloads with unique capabilities is offering valuable insights into the lunar surface, providing a plethora of information to the scientific community and conducting a comprehensive analysis of the moon's topology. The Chandrayaan-2 mission paved the way for Chandrayaan-3's soft landing on the lunar surface. On July 14, 2023, ISRO's heavyweight launch vehicle LVM-3 M4 successfully launched the highly anticipated lunar mission Chandrayaan-3. The Chandrayaan-3 integrated module is configured with a propulsion module and a lander module with the rover housed within the lander. The lander module of the Chandrayaan-3 has been enhanced to ensure greater durability and resilience, surpassing the capabilities of the Chandrayaan-2 module. It has been reinforced to independently adapt to a wider range of variables, enabling a safe and soft landing. Detailed tests have been carried out for the performance evaluation of the lander systems on Earth to ensure the capability 3M3 rocket successfully deployed the Chandrayaan-3 satellite into an elliptical parking orbit at a distance of 170 by 36,500 kilometers. Following the sequence of Earth burns or EBN, the spacecraft was precisely inserted into trans-lunar orbit. On August 5, 2023, Chandrayaan-3 successfully entered the lunar orbit at an intended distance of 164 kilometers by 18,074 kilometers. Then the spacecraft achieved a lunar orbit of 153 kilometers by 163 kilometers through a series of lunar burns. On August 17, 2023, the lander module was successfully detached from the propulsion module. After a series of maneuvers, the lander module was successfully brought into a 25 km by 134 km lunar orbit. Consequently, the lander module initiated the power descent phase to achieve a soft landing near the south pole of the lunar region. Then, the much-anticipated spacecraft landing on the lunar surface had begun. On August 23, 2023, the long-awaited Chandrayaan-3 spacecraft achieved a successful soft landing on the moon. The entire country witnessed the event and cherished the triumphant occasion. The entire nation was filled with pride as they witnessed the relentless efforts of the Indian Space Research Organisation. The Honourable Prime Minister, Shri Narendra Modi, witnessed the triumphant event through virtual mode and applauded the valiant efforts of the ISRO scientists.
चंदा मामा बहुत दूर के हैं, चंदा मामा बहुत दूर के हैं। अब एक दिन वो भी आएगा जब बच्चे कहा करेंगे चंदा मामा बस एक टूर के हैं।
On August 24, 2023, rover ramped down from the lander and India embarked on a historic moonwalk. After coming back from South Africa and Greece, the Honourable Prime Minister promptly headed to the ISRO Telemetry Tracking and Command Network, ISTRAC, in Bengaluru on August 26th. During his visit, he expressed his admiration and delivered a historic speech about the achievements of ISRO scientists and the lunar mission Chandrayaan-3. He also saluted the pivotal contribution made by the women scientists of ISRO, the Nari Shakti, in the successful accomplishment of India's lunar landing mission. By achieving this historic feat, he has given it the names
चंद्रयान-2 के पद चिन्ह जहां है, वो स्थान आज से तिरंगा पॉइंट कहलाएगा। और जहां पर चंद्रयान-3 का मून लैंडर पहुंचा है, वो स्थान आज से शिव शक्ति पॉइंट कहलाएगा।
To commemorate the grand success of Chandrayaan-3, the Government of India announced
23 अगस्त को जब भारत ने चंद्रमा पर तिरंगा फहराया, उस दिन को अब हिंदुस्तान नेशनल स्पेस डे के रूप में मनाया जाएगा।
To honor India's amazing space exploration journey, MyGov, in collaboration with ISRO, conducted the Chandrayaan-3 Maha Quiz, in which millions of students participated. The remarkable achievement of Chandrayaan-3 highlighted India's impressive technological advancements, scientific expertise, and unwavering dedication to the exploration of outer space. India's success will further strengthen its position in the global space community. The success of this mission will ignite a sense of pride and inspiration in future generations. The wonders of space have always captivated humanity. For the maiden Indian human spaceflight mission, Gaganyaan, ISRO, in collaboration with the Indian Air Force, selected the crew from a pool of talented test pilots. These pilots underwent a battery of clinical, aeromedical, and psychological tests. Finally, the National Crew Selection Board recommended 4 test pilots from the Indian Air Force for the Gaganyaan crew training program. The selected crew members were trained at the Gagarin Cosmonaut Training Center, Russia, for a period of about 13 months. This training covered various aspects of a space mission, such as parabolic flights, survival training in off-nominal snow, desert and water landing, as well as extreme environment stressors. After returning, the astronauts are being trained in the newly established training facility. Through the Gaganyaan crew training simulators, mock-ups and state-of-the-art virtual reality tools, the space crew is also getting trained in various human-centric products and survival scenarios. Physical fitness of the crew is maintained through a rigorous physical training regime. A specialized yoga module is also incorporated in the physical training curriculum for holistic health management of the astronauts. They will also be assigned for ISRO NASA mission to the International Space Station, announced by the Honorable Prime Minister. This incredible feat will take Bharat to greater heights. Akasha Bhavantam Pratikshate.